Hey everyone, let's just give a few minutes for people to join. Thank you for being on time. Before we start and while we are waiting the others to join, I would like to ask you to vote your answers to the poll questions, and we will be sharing the results right before the presentation starts. Also, please feel free to submit any questions regarding the presentation in the Q&A section below. And those questions, we will address them at the end. Here are the questions. All right. I guess we can start. So thank you all for joining us today and for being part of Data Science, Machine Learning, and AI group. As some of you may know, my name is Bojana, and I manage event marketing at Centelli Solutions, which is a data science and advanced analytics solution provider based out of Charlotte, North Carolina. We offer a wide variety of services, including data analysis, master data management, business intelligence, and reporting, machine learning, and AI across industries like healthcare, manufacturing, financial services, and insurance. Usually we host this monthly data science meetup in person, but for the time being online, And while Charlotte is the biggest group, we also have chapters in Birmingham, Alabama, and Jacksonville, Florida. Additionally, on the side of these meetups, I would like you to invite you to our upcoming Centelli event on July 15. You can find more information on Centelli's social media, and I will also share the updates on the upcoming events in the meetup groups. All right, so I'll be moving on to our speaker for today, and I will be as brief as possible since his presentation is so exciting and insightful. Alex Liang is a machine learning enthusiast and software engineer. He previously worked in data science at American Tire Distributors, Red Ventures, and he recently joined Microsoft in Redmond, Washington as a software engineer. And then again, before I hand it over to Alex, I would like to ask you to please submit your questions meanwhile, so we can have time to address them all at the end. Alex, thank you for joining us today all the way from Washington. Alex, can you hear us?
Yes. Hey. Yeah. Thanks for the intro, Bayana. Yeah, I was just I was muted a moment ago. All right. Should we take a look at the poll results before I get started?
Sure.
Okay. Let's see. So I'm just gonna quickly take a look at the poll results so I can better adjust kind of my pacing and how I would go about doing this presentation.
Do you want me to go through the questions?
No, I can see it actually.
Awesome.
Cool. All right. It looks like we have quite a few people that have intermediate level familiarity with Python, data science, and some of the cloud technologies. So that's good. Just to make my maybe presentation a little bit more engaging, let me start my video. So, oh, well, okay. So cool. All right. I think we can just get started. Well, welcome everyone. And thank you, Bayana, for the opportunity, and thanks, Sintali, for the opportunity to invite me here to do this presentation. So again, here what I'm gonna go through here is MLflow for ML pipeline monitoring and tracking. Um, and OneNote, whatever that I'm gonna go through today here is purely on the machine learning, sort of on the open source machine learning aspect of MLflow, and it's just my own opinion. And this is, not the opinion of anyone else or my employer or whatever. So just a quick disclaimer there. All right, so the agenda for today's presentation is primarily going to be a quick introduction to MLflow with a emphasis on the MLflow's project tracking API. So based on the poll result, it seems like we have a somewhat fairly technical audience here today. So I'm going to probably spend the majority of the time to do actually a code demo so that it makes a lot more, makes better impression on your end. All right, so why do we need MLflow? So probably not everyone has heard of MLflow, but from the name, you probably can tell it is a tool that has something to do with machine learning. And right, so what is MLflow? So MLflow is an open source framework that has many different APIs to work with Python, Java, R, that helps you track your machine learning flow in a sense. So in a machine learning setting, either you're a data scientist or you're a data engineer on a machine learning team, or you're an analyst or you're a software engineer, you always deal with this kind of flow like process in machine learning where you gather data, you build model, or you do data exploration analysis, and then you build model. Then you do model training, you tune your model, do hyperparameter tuning, and later on you may deploy your model, so on and so forth. So the whole process is very functional in a sense that you have input data and then you have output model or prediction, and it just goes from left to right or from top to bottom in a flow fashion. So one of the issues within a machine learning pipeline process is that machine learning in itself and data science included is very research oriented. So if you're a data scientist or an engineer, you may always find yourself trying different parameters or trying different methodologies in your data processing that results in different performance of your model. And sometimes when those things get too messy, you try too many parameters or you try various different approaches. It's hard to make them organized. So you quickly find yourself in a situation where hey, I have a good model, but I don't know exactly how I can backtrack my way back to the original data. So I don't know my path that I took to get here. So so one way to tackle that problem is to have a framework to help you. Basically, what if we have a coding framework where we can log whatever we did in different experiments or model training process, and we can put that up on a web UI dashboard so that we can always keep track of what we've tried, what experiment we ran, and what kind of model parameters we explored. So there's going to be one place that we can all look at and be able to do tracking, logging, and metrics monitoring of your machine learning workflow. So that's basically what MLflow does. So it is very relevant for data scientist, data engineer, or analyst, or software engineer in some cases as well. So I have already kind of gave you a summarized version of what MLflow is. So feel free to just go to mlflow.org to check out more information. By the way, I'm not sponsored or whatnot by MLflow. This is just an open source package that I found very helpful for me. And even before in my previous working experience, we use something like MLflow to do tracking. So it is definitely very useful either for individual kind of data science or machine learning practitioners, or in a production setting. So like I said, today for MLflow, we are going to pay more attention to the MLFlow Tracking API. So MLFlow as a platform has many different fronts. So it has a tracking service API, it has a project API, it has a models API, and it even provides you a centralized model registry within the package itself. So it's actually quite comprehensive. The thing that I find very useful for me is the tracking API, where through simple code changes, you can easily track whatever component or parameters or metric you want to track during your ML workflow. And they already pre-built a web frontend to display all the tracked numbers that you have. So it's very easy to use. So we're gonna focus on the MLFlow Tracking API today. So before I go into the code demo, just to give you a flavor of what that's like. Remember I said the MLFlow Tracking API is very easy to use. So if you look at the slides on the left-hand side, right, on the right of the URL, you see this is a simple, very small script that I wrote that basically demonstrates how you would go about use MLFlow. So let me see if I can point this thing here. I'll do this. So if you see my laser pointer here on the screen, so all you need to do is import MLFlow, and you use MLFlow.setTracking URL to point your machine learning experiment or whatever you want to call it to a particular tracking server. And then once you do that, in the process of running the script, you can use MLFlow different APIs to log whatever number you want to log to this server. So in the code demo today, I'm going to show you how to simply set up the server remotely in a cloud environment, and how you would also start running your machine learning experiment locally from a local laptop and see how that interact with each other. So that's kind of, this is kind of the code aspect of it. So over here in the bottom, this is the web UI interface. Of course, this is kind of small right now. You can't really see it clearly, but we're gonna see this right after this slide. So some of the example APIs. You see, for MLFlow, they want to provide as much flexibility as possible. So during a particular MLFlow run, under some experiment, you can log parameter. You can log a dictionary of different parameters. You can log different metrics. You can set tags. And one of the most important and useful API is log artifact or log artifacts, which both enable you to actually save actual files or pickled sklearn models, or whatever that you think is significant enough, you want to keep it somewhere. So you can log such artifacts all the way to the MLFlow server itself, or better yet, you can log it through MLFlow server to a cloud storage bucket, which is something that we're going to go through today. So this all sounds quite exciting, right? So this is the overall structure of our code demo that we're going to go into in the next 15, hopefully 15 minutes or so, and then we can spend more time discussing Q&A and whatnot. All right, so for our MLFlow code demo, what I'm gonna show you is I'm going to show how you can set up an MLFlow tracking server on a GCP virtual instance, and how we can also use a GCP Google bucket. It's a storage store to communicate back and forth with the MLFlow tracking server. And then we are going to run some local machine learning small scripts, and it's going to post whatever tracking that we want to track all the way to the cloud environment. And then we're going to see a web UI of it. So that's going to be our MLFlow code demo overall structure. So you can see this is very, very useful in a sense that you can literally just set up your own server, either on a GCP or you can run it locally as well. But to me, for the demo purpose, I feel like this is much more relevant. Once you set up the server, you can post new experiments onto that server, track whatever process or progress you have made, and whatnot. You can even access it throughout the internet, like with great visibility. So let's see. Let me click on this link. All right. So right now, what you are seeing is this is the MLFlow server that I set up from out of my own Google Cloud virtual instance VM. So it's a Ubuntu VM on the Google Cloud, and on that particular VM, I installed MLFlow. So after installing MLFlow, you can run MLFlow server start, like a command like that, so that it'll start a server. So here, this URL, the 35.223 blah blah blah. This URL is actually open for everyone. So maybe I can copy and paste this to our chat. So you can. Let's see if I can post this. Yeah, there's a chat. All right. So if you are curious, you can actually click on this link, and you can actually see the same website that I'm pointing out right now. So I'm seeing a couple of questions. I'm going to wait till the end to discuss these questions. So I'm gonna proceed from here now. So if you use this link, you can access the same website that I'm looking at. And upon logging into this website, it's pretty simple to see that we have a section of different experiments. And within each experiment, you have many, many different logs of runs, essentially. So you can imagine, hey, I want to train a machine learning model for a customer churn use case. So you can set up a experiment called customer churn. And within that experiment, you can try running different models many times. What's cool about this is you can publish this URL to someone else, and they could point to the same experiment, and they could run different models within that same experiment, but with a different username. So you can actually see, A Leon, this is me. I ran 5 models, and I have a certain metrics showing here, and somebody else may have run some other models and show different metrics. So it's all really easy to use. And so if you look at one of the runs here, this is a demo script that I just ran like half an hour ago, almost an hour ago. It's basically a demonstration of how I would run a Keras script. And during that process, it actually logs the loss and validation loss of my neural network model. If you click on this, you can actually see pretty good UI here. So I encourage you, as I go through this presentation, to use that link and log on to this website, and you can actually see these different plots and stuff. Like I said previously, I mentioned one of the cool things about this tool is you can log your artifacts. You can log your artifacts in code, and it'll show up here. And you can see I have saved my Keras neural network model as a JSON as the model structure, and then as a .h5 file as their model weights. So this is kind of a 2-minute version or go through of this MLFlow web frontend UI. So in order to do all of this, you don't have to worry about anything related to HTML or JavaScript or anything. Not like, at least not yet, right? I mean, if you just want to run everything out of the box, this is what it looks like. Of course, you can go into MLFlow's own package, and you can modify different places to customize how this looks. But out of the box, it already looks quite nice and really easy to use. So let's dive into some code. Let's see here. Maybe before I do that, is there any kind of big questions that you still want me to answer before we go into technical pieces?
There are some questions, but they are not regarding the code.
Okay, sure. That sounds fine. Okay, then I will continue and go into the more technical piece of this presentation. Let me close this. close this as well. All right, by the way, all the code I have done for this project has been pushed to my personal GitHub account. Let me also share this with you on the chat so you can take a look at this and feel free to clone this and do whatever you want with it. So we can just start from this web view here. So on my GitHub, you will see the code base. And it's basically divided into server and client. The server piece is whatever that's going to be run on the remote Google Cloud VM. So if you go through the README, it basically summarizes, hey, come here, set up your VM, install your Python and dependencies. MLFlow is one of them. And make sure there are a few configuration things you need to clear up for this before you get everything running. So we're not going to pay too much attention to all the setup process with Google Cloud, because I feel like for Google Cloud, it's one way. For Azure, it's another way. For AWS, it's probably something else. But most of the time, they look somewhat pretty similar. And if you really want to go through setting up this process on your own on some other cloud provider, be sure to just go to MLFlow's documentation and go through their documentation of how to set up the server. They actually have pretty detailed explanation of different servers. Different cloud providers. All right, let's see. That's the server part of the MLFlow. On the client side, it's really even simpler. You just make sure MLFlow is installed, and I have two scripts that I'm gonna quickly run today to show you how it works, how you can post client-side sort of machine learning workflow, post whatever metrics you want to track all the way up to the cloud. All right, to make things easier to look at, I have two Visual Studio Code editors open. They are essentially pointing to the same code. So here, this one with the light bluish, not light bluish, dark bluish and greenish code editor. This is the one that's currently opening up a code base on my laptop. So I have a MacBook Air. This is where it is at. So you can see this address here. This looks like a MAC address. So this is a local copy of the code base. In this code base, I have, let's see. I have here you can see the same structure that we just saw on the GitHub webpage. You have the client folder, have the server folder. So let's just use this code editor to run whatever we want for the local ML learning, machine learning scripts. And just to make it easy to distinguish different pieces, I'm over here opening up a very high contrasted, very dark Visual Studio Code editor. And this is actually remotely connected to my Google GCP VM. So it is just a very normal Ubuntu machine on the GCP cloud. So within this GCP cloud, let's see, we have projects, we have a Meetup flow. Oops. So this is our Meetup MLFlow folder. Within this folder, we have all the files we need. So again, this is pointing to the same directory. So let's see, server, this is where we want to run this shell script right here. So in this shell script, I have commented out some basic examples where you can run your MLFlow server, and it's going to open up the server, but with a lot of default settings. So if you just run MLFlow server with a host port open, like so, it's going to save whatever meta information about your server to your disk on this VM. It's also going to save whatever artifacts locally on the disk of this virtual machine. I mean, those two things are fine. But one of the things I wanna kind of utilize is to utilize a Google Cloud bucket. So here, instead of doing a simple MLflow server and host, I'm doing MLflow server, and I gave it the optional argument to point the artifact store to a remote Google Cloud bucket. And then again, I'm using the same 8888 port. So here, this ML bucket is actually viewable here. Bucket details. This is that bucket that I set up on my own GCP account over here. So these are the previous runs I have already done with that server. We're going to look at more details of this once I start running some experiment. So let's see. Actually, no. All right, in a tmux window, I have already had this server up and running. This server is setting up the website that you're seeing right now, which is this window right here. So here, if I cancel this, and if you refresh this, this website will be down, right? Because it's no longer serving the content of this MLflow tracking server. So I'm gonna restart this. So once I do this, this shell script gets kicked off and it is executing this command, right? And if you look at the log or the console messages here, if you are familiar with Python's Flask and Nginx server proxy, this should look quite similar to you. It's probably what's under the hood for the MLflow server implementation. So this is quite easy to use, and it's actually quite easy. June2020 is a very popular Python friendly server. So great. So this website is back up and running, and it's pointing to the previous runs that we are looking at right here. All right. Cool. So on the server side, it's really as simple as this. From a code perspective, this is all you need to run. And if you want to run this on your own, be sure to go through the README and let me know if you have questions. You can message me on LinkedIn or whatnot. But there are a few small caveats that you will have to go through when it comes to opening up your ports on your cloud VM and that kind of stuff, like setting up proper permissions. But overall, it's not that difficult to set up this server and make it up and running and make it available pretty publicly to all the audience on the internet. Great. So this is how you set up the server. And let's see. Okay. So next, let's go to how we want to run client-side experiments. All right. Now we're back with our local copy of the code base, and in the client folder, we have these different files. For demo purpose, I have made two demo scripts. One is demo Keras, one is demo sklearn, both of which are Python packages that any normal data scientist would use to run their machine learning experiments. So let me point out a few things in the first demo sklearn script. So here, if you get rid of MLflow related code, it would actually look somewhat similar to whatever you already have here. The real kind of magic here is import MLflow, set your tracking URL. This is very important. This is going to point to the proper UI or like web front end for MLflow. And this URL also takes REST API calls. So when you do MLflow.log, you actually go to this URL here and do a post, basically do a REST post and post with parameters of criteria, value of sklearn model.criteria. So this should, if you're like familiar with Python programming to some extent, this should look somewhat straightforward to you. So I have a main function right here, which basically load some data set. In this case, it's the iris data set. It's the one of those very classic data science data sets that you can play with. And we are training a simple decision tree classifier with the data and target. Uh, Again, here the goal is not to train the best model here. Here I'm just trying to demonstrate within a machine learning training workflow how you log parameters and so on. So you do all the training part, and what comes after this is the ML flow pieces. So you can log different parameters within this function flow, and then you can finally log the trained model up to machine learning, up to the ML flow server. So this is the function that we're going to run. So just by I think this is a good habit to have. I wrap this part of the code within a main function, and I have a main function here that will call this. The reason we do this is kind of have a good try and accept clause that that is safer to use when you use MLflow or this kind of somewhat interactive service. So what we're doing here is we are starting a MLflow run under this experiment, Meetup demo. And within this experiment, we run this experiment. We kick off this new run, and we give it a name, demo sklearn, let's say 1. And then it's going to call the main function. So everything that happens within the main function actually lives in the context of this with block. So you can be sure that the MLflow that we are using here within the main function is going to be kind of in the same context as this run, and further as at this experiment, and originally pointing to this URL. So this is kind of the script structure for this demo sklearn. So let's try run this. All right, so it's probably going to take a few seconds. And if you are looking at this website right here, you do a refresh, at some point that new run is going to pop out. So it looks like it's still running. All right. Now you can see there is a new entry right here, which is just kicked off a few seconds ago. And the run name is, well, we just renamed it, demo sklearn 1. It's triggered by me. So far, it hasn't finished yet. So if this finishes, it'll give you a green check mark. If it doesn't finish or for some reason failed, it'll give you a red cross. Hey, great. So it looks like it finished successfully. And during that process, we have logged 2 parameters, criterion and splitter, and we gave them some generic. It's not actually generic. It's actually part of what the sklearn model, trained sklearn model had, which is Genie and Best. We pass these parameters here, and we log the artifact as a sklearn model artifact. It has a pickle model file. It has a Kata YAML file. It had a ML model file. So this ML model file actually relates back to MLflow's model API and project API. So if you have more interest in that, you can look into it. Basically, this will allow you to, in real time, actually serve your predictive model using MLflow as well. So we're not going to go too much into that today. But that's something really interesting as well, especially when it comes to production setting, when you want to train your model and at the same time keep them in the same storage and then kind of serve them when you want to. So what's cool about this is you even have git commit messages of that code base that we just run our script at. This is going to be super cool and interesting because sometimes if you have a lot of people running different models within this same experiment, they may come from different git commits. And you want to distinguish them so that you can see which commit points to what model and how they perform and so on and so forth. So that's very cool that you have this option here. Cool. So this is the sklearn demo script. Let's look at something else. Let's look at this demo Keras script. So everything, well, maybe not everything, but most things are very much the same. You set the same tracking URL at the top of the script. For the main function, you set up your experiment name. And before you kick off a run, you give it a run name of some sort. Let's change to Keras1. And maybe for an interesting experiment, let's rename this Meetup demo. Let's say, hey, we want to try a whole suite of different models, which are neural network models that are part of Keras. Let's set the new experiment of Meetup demo Keras. So currently in this website, you don't have Meetup demo Keras. So if this experiment doesn't exist, it should basically create a new experiment called this, and it's going to post new runs under that experiment. So it's going to be a totally different experiment now. So let's try run this. All right. So we are actually loading a fairly small data set, and we're building not the most complicated model. It's just a sequential machine learning model that has different layers. You can see here, if you look at the log message here, it says Meetup demo Keras does not exist. Like this experiment doesn't exist yet, so it's creating a new experiment and with a name of this. And then you can see we are training our neural network model with decreasing losses. So that's good. And training loss is decreasing, so is validation loss. So this is a good sign. All right, scrolling all the way to the bottom. Now, we are seeing that the training process has stopped, but this script hasn't stopped yet, which basically means it's probably uploading models and the results and parameters up to the server. Now I just refresh this, so immediately you can see this new experiment that we just logged, and you see this run that hasn't actually finished yet. Let's see. Oh, now it finished. So cool. Let's look at what we have here. So once you click to this run, there's a lot of parameters that we could have logged. We didn't log it, but that's fine, right? I mean, you can even like write notes here. We didn't log all the parameters, but you can. And this is actually going to persist for this particular run, which is very convenient. So like if you have two people working on different runs, or you have many people working on different model architecture, you can come here and add notes. Be like, the new neural net architecture works better with unbalanced data set, or like something like that, like with a comment, right? So this is very easy to use. Now here in the metrics part is what I want to show you, the visual aspect of this tool. Basically, you can try, so whatever metrics you logged, you can view it with this XY axis. So in this case, we're looking at both training loss and validation loss, right? Simultaneously, you can even toggle on and off to look at whether you want to look at raw points or not. You can smooth it out if you want, if the signal is very jaggy, or you can change the steps, relative time, and everything. So it's really easy to use. You can even toggle it off to look at the log scale. So with this tool, you can imagine you have different runs under different experiments, and you keep everything you have done within this server in this central place, and you can look at everything you have experimented. So that's like really cool. So now let's take a quick look at wherever that we store the artifact. Remember, we are storing the artifact in this ML dev bucket. This is the bucket that I set up on my own GCP account. Let's look at here. So basically, 0 experiment is the first one, the ML demo. This is the ML demo Keras as experiment number 1. And we just post one run to it. So this is that run ID. And in the artifact section, you see the model.h5 and the model.json. They are exactly the same thing that we saw from this web interface right here. So everything is basically all linked up and all simultaneously kind of available. And you can download this, or you can export whatever training process as a CSV for this particular experiment, and whatever you want to do. it's actually very easily doable here. So let's see, we have about 20 minutes left. I don't want to go into too much detail now because I feel like we should spend the rest of the time doing some Q&A. But this is essentially all the technical pieces you need. You need to set up your own MLflow tracking server to track your experiments. So I'm going to stop it here now and open up for questions. Boyana, do you think, yeah, I can
Sure.
let you take, yeah.
Sure, there are two questions. So this is a question from Jay. As he can see, you worked at as a data scientist previously at ATD and Red Ventures. Why did you move towards software engineering with Microsoft? Why not continue as a data scientist? Actually, I also wanted to ask you that.
Yeah, that's a great question. So I would say it's kind of a personal preference. I like engineering a lot. And that's also kind of my graduate school training, which is in computer science and machine learning. And a lot of engineering stuff that I did at Georgia Tech really stuck with me, I guess. So so in that sense, I kind of want to move towards software engineering with Microsoft, and maybe other aspects is like in data science and in machine learning. I feel like again, this is, I guess, just a personal choice, right? I feel like I kind of want to do engineering mostly in the future. So that's why I kind of migrated to software engineering field.
Well, congratulations on the new role.
Thanks.
We have a question from Melissa. Could you share with us why you choose GCP over Azure for your demo?
Yeah. Honestly, I didn't choose. I didn't actually choose anything. And the reason that I say that is like I just find whatever that I felt more familiar with. Since I just transitioned over to Microsoft, I started using Azure, but I haven't used Azure before. And as far as I can tell, Azure is a great platform as well. But so far, I have pretty good familiarity with Google Cloud since I started using AWS in graduate school. Then I tried something with Google Cloud. Yeah, it's not even a preference. It's just in the time in my previous lives, I have been using these two things, and I wanted to set up this demo quickly for you guys. So I went with whatever that I felt I'm familiar with. But I'm sure Azure is like super powerful right now as well. Yeah.
Awesome, thank you. So then we have a question from Raja. Azure machine learning vs MLflow, which is better and what is the difference?
Yeah. So I will talk about the difference first. First of all, MLflow, being open source and all that, MLflow to me is more for project tracking and model versioning. It's not as robust as Azure ML for sure, because Azure ML is a full-fledged machine learning platform where you can basically do everything. But in the case where you are pretty hands-on with Python programming, you want to control more knobs. Or tune your models with more flexibility and want to go a little bit scrappy, then I think MLflow is a great choice. But MLflow is very limited in functionality compared to Azure ML because Azure ML basically can do everything. MLflow is just here to help you track your machine learning experiments. That is somewhat lightweight and easy to set up.
Awesome, thank you. So then we have a question again from Raja. What is the difference between working as a software engineer in machine learning vs working as a data scientist at Microsoft?
So I've only started working at Microsoft as software engineer. So I've worked at other companies as data scientist. I can only kind of tell you in general the difference between working as a software engineer and a data scientist. So working as a data scientist, my personal opinion is you have some technical time to do coding, but you also have a significant amount of time that you will do that will spend on like doing project management. You have to be very analytical. You are very close to the business side. You will do a lot of data manipulation, digging, mining. You will set up A/B testing experiments and whatnot. So a lot of times you are the analytical person for a particular product or business function as a data scientist. For a software engineer, I think the main job responsibility is about building stuff or like fixing stuff. So that's mainly what a software engineer does, as far as I can tell so far. But yeah.
Thank you. Then we have a question from Vishal. Can you shed some light on how MLFlow can help in production development of models and overall integration in a DevOps framework?
Yeah. So in my previous experience, we used MLFlow as a machine learning monitoring system to monitor metrics, model training process, even data pipelines. What's cool about MLFlow is you can even post MLFlow tracking requests from a Docker container. So let's say you have a team of data scientists that build models, and you can require them to Dockerize whatever they've done for a particular model in a container, and then they kick off, they deposit that container somewhere, and then they kick off a particular run of a machine learning pipeline, and then it can show up on the MLFlow. So MLFlow itself is relatively lightweight and easy to use. So you can basically either set up one server just to run MLFlow, or I can imagine you can even set it up in a app engine type of environment where you can take a lot of requests from different processes. So it's actually quite flexible.
Great. I hope that answered the question. So Wei is having trouble getting the same screen on MLFlow site. Would you mind?
Yeah.
Yeah.
Yeah, I'm doing that right now. Let's see here. Try this time. Yeah, okay.
And then we have from Chandra, how well this work under Python virtual environment? We have different environment for different build.
Yeah, I think it doesn't matter too much. All you need to do is like in each Python virtual environment, you have the proper MLFlow installed. Then from the client side, like let's say you have like 3 different Python virtual environments, each running different machine learning processes. As long as they are pointing to the consistent MLFlow URL, they can post MLFlow logins to that same server. So that shouldn't be a problem. Yeah, on the server side, unless you want to run like many different MLFlow servers, with each one tied to a particular Python virtual environment, even if you do that, all you need to do is be careful that you are configuring the URL properly. Like you don't have like duplicate URL MLFlow server and then occupying the same port. I'm pretty sure like if you have one server up occupying port 8888 on one machine, you're not going to be able to open another server with the same port on that same machine. So yeah, it shouldn't matter. Yeah.
Awesome. Thank you, Alex. So I have a question here from Raja. Can we have a demo on Azure ML? So Raja, I would like to, Alex, sorry, I would like to answer that. You can take a look at Syntellis events and news page where we have videos on Azure, but also I believe you can reach out to Alex separately for the demo on Azure ML. Awesome. Then we have Wei. He just recently finished up graduate program in business analytics, and during his coursework, he noticed that there are quite a few similarities between business analytics and data science. And you just mentioned that data science requires to be closer to the business side of things other than ML. Any other tips for business analytics that want to enter data science?
Yeah.
Thanks in advance.
Yeah. I think data science is an interesting field in that if you're a business analyst, you can add on technical skills and work towards a data science role. And if you are a technical person originally, you can learn business skills and try to migrate towards data science as well. So it's a great intersection of many different disciplines. So as a business analyst, other than ML, I would, my personal experience is that being able to understand how business ties back to fundamental statistical problems is very key. So a lot of the times in the industry as a data scientist, sometimes you build models. A lot of the times you have to communicate with business end user. So if you're a business analyst, you already have a leg up on that front. Like you already know the business well, you have a pretty good analytical mind. But at some point, you're going to be asked with question of, hey, we in business, we can do A or B, like which one should I do? Then that comes down to statistical background. That comes down to your A/B testing chops. That comes back down to like, can you carry out a legitimate A/B testing process where you can talk about statistical significance of different approach in a particular business strategy fork. So statistical prowess, I guess, is very important. Another thing is, as a business analyst, I would also say that being able to do quick data manipulation and complicated data manipulation is very important as well. So many times as a data scientist, you either are a very strong SQL coder or you're a very strong Python pandas coder. Whatever you are really proficient in manipulating large quantity of data that is messy. So that's also very important. Yeah.
Great. Hope that was helpful to A. So we have one more question I would like to ask everyone. We still have time to address a few more questions. You can go ahead and submit them. So we have a question from Bala. I'm a project manager, technical in general, but not a programmer. What skills might be needed to manage these AI projects?
Right. Okay. I think to work in data science as a data scientist, you don't need to be great. You don't need to be a great coder, but you do need to be very comfortable doing coding. As like from my own experience, for most data scientists that I have worked with, if you ask them, do you prefer to code all day or doing something else, they would say they prefer to do coding all day. So from like one aspect, you can almost say a good data scientist is a software engineer that likes data. Like you can almost say that because like coding is just something that is very fundamental to being a good data scientist. Because if you're a really good coder, the technical pieces in data science will come really easily and natural for you. So say like for Bala, if you want to transition to project manager, my only suggestion is maybe look at HackerRank and do Python coding exercises, just to be more proficient with Python, just be more comfortable looking at code. I think that's going to be really helpful.
That's great answer. Thank you, Alex. So we have Kirill asking, are you aware of any companies that provide MLFlow as a service so that he don't have to host it himself?
I think so. I think there's a provider called Neptune or something. Maybe. Yeah, I think so. But I mean, hosting it is not gonna be too like, it doesn't cost too much, and it's also kind of like a good practice of setting up cloud environments yourself. So it's a good learning experience too. So, but yeah.
Yep. All right. Chandra, can this tool transparently handle different Python virtual environment? She's not sure if they have such an integration to activate the environment internally.
Okay. So if I understand your question correctly, I would say yes. So on this website that we're sharing, on this MLFlow link that you're seeing, if you run this from different virtual environments, either Anaconda environment or other PyEnv environments, there's one place, this version thing, this user, these two things will be different. So you will like, for MLFlow server side, it doesn't really distinguish much between, well, it does distinguish between different environments, but it's not going to be, it's not going to crash because you post some experiment from one virtual environment and you post another experiment from other virtual environment. It's just going to show up in the same MLFlow server as different user and different version. So you can definitely distinguish between different virtual environments. Yeah.
Awesome. Well, I think that's about it. Thank you so much, Alex, for the presentation. It was a pleasure having you as a speaker today. Thanks everyone who participated in the webinar. Follow us for more events to come. And Alex, congratulations again on your new personal environment and role.
All right, great. Thank you, everyone. And thank you, Bojana, for setting this up. Thanks.
Yep. Bye-bye.
Right. Bye. Take care.